With the uprising advancement in technology, I saw the lack of technological support in farming, especially in papaya plantation. This is why the detection and identification with analysis of Carica papaya leaf diseases using Android title is proposed. By the way, I am John A. Bacchus. Let us continue with the key points of this proposal. Philippines is one of the Asian countries that primarily exports fruits in the markets of many Asian countries, such as South Korea, Hong Kong, Japan, Taiwan, the Middle East, China, and Singapore. Papaya is more frequent produced in the Visayas and also Mindanao areas. Island of Luzon has limited production due to the existence of devastating viral disease. Shown in the images are the problems that papaya plants face. This will lead to a very huge problem because it will not produce economical crop, which will lead to profitable loss. Problem statement. A lot of farmers face extreme problems in identifying the disease because they need more human intervention to lessen that people go in for smart farming. Once a papaya tree is infected at a young age or stage, it will not produce an economical crop, giving the farmers a profitable loss, which was mentioned earlier. The visual observation of experts is the major approach in practice for detection and identification of plant diseases. The expert will look closely at the leaf and sometimes uses magnifying glass. This is because of the lack of technology in identifying the papaya leaf disease, which will require continuous monitoring of experts, which might be excessively costly in large farms, time-consuming, and irritating for those people who are unfamiliar with the plant. For the objectives of this study, the general objective of this research study is to develop a system that detects and identify a papaya leaf disease. In order to achieve this, specific goals are laid. Use convolutional neural network or CNN as the method for identification and detection of the papaya leaf diseases. Create an Android application for the portability of detection with Raspberry Pi. Use confusion matrix for data analysis of the performance of the system. Evaluate the accuracy of the detection, and analyze and recommend treatments or control of the detected papaya leaf disease. For a review of related literature, let me show the matrix for the author and the keywords that were used in the paper. We have papaya diseases, convolutional neural network, software application, and programming language. For the conceptual framework, we have the papaya leaf images as our input. The processes involved are image pre-processing, data augmentation, and image analysis through mobile nets. And the output would be identified papaya leaf with treatment recommendation or control of papaya leaf disease. In order for this study to be successful, let's move to the specific part on how to solve the problem. The waterfall model will be used as the model for the development of the entire system. Each phases are divided into categories, which are labeled the steps on how to solve the problem. The lack of technology of papaya leaf classification is the main problem of papaya plantation. Thus, all requirements needed to make this study successful are in this phase. For phase 1, we have the requirement analysis. This phase is mainly all about gathering what are the types of diseases in a papaya leaf. Under phase 1, we have 2 steps. First is research related literature to identify certain parameters needed for the papaya leaf detection. Then, classify different papaya leaf diseases. Let's be more specific. For the requirement analysis, step 1 would be research related literature to identify certain parameters needed for the papaya leaf detection. This step focuses on gathering data through journals, web sources, published books, and etc. Also, interviewing papaya farmers will be done for further knowledge about the diseases. The primary objective of this step is basically classifying the parameters needed for the papaya leaf detection. For the second step, classify different papaya leaf diseases. From different sources, there are a lot of papaya diseases. But upon interviewing the Bureau of Plant Industry in Region 11, the most common papaya leaf diseases here in Mindanao are the following. We have the mealybug infection, the brown spot leaf disease, powdery mildew, black spot disease. So these are the diseases that are classified and will be the dataset of the study. So also, the healthy papaya leaf and an unknown disease will also be added for training. After that, we are going to go to the phase 2 of the waterfall model, which is the system design. Under system design, we have step number 3, which is to determine the hardware and software requirements. Shown in this picture is an example of a Raspberry Pi with an LCD screen and a camera module. The app will be developed in Python. With the help of mobile nets and transfer learning, the CNN structure and its layers will be built. Raspberry Pi with LCD screen and camera module will act as the hardware for this research study. Let's move on to the next phase, which is implementation. This phase shall be conducted after designing the system that are needed to be done for detection and identification for the papaya leaf diseases. This is also called the development phase. The datasets from phase 1 will act as the database of the proposed application. The expected output of this phase is the development of the identification and classification with analysis of different papaya leaf. In phase 3, we have step 4, which is to collect datasets for the papaya leaf diseases for basis, image pre-processing, augmentation process, training of dataset using mobile nets architecture, and to link the application to the Raspberry Pi with LCD screen. To be more specific, for step number 4 to collect datasets for the papaya leaf disease for basis, we have the following as our datasets: mealybug infection, brown leaf disease, powdery mildew leaf disease, healthy papaya leaf, black spot leaf disease, and also the unknown disease. For step number 5, which is image pre-processing, in order to obtain good feature extraction, the final images that will be used as datasets for deep neural network will be pre-processed for consistency. For step number 6, the main purpose is to increase the accuracy for datasets and introduce a slight distortion to the images, which helps in reducing overfitting during the training stage. For step number 7, we have the training of the data using the mobile nets architecture. In this stage, a mobile nets is already a pre-trained network. So instead of creating layers from the scratch, this architecture will be used for transfer learning. The pre-trained network transfers all the learned parameters and is set as a feature extractor for the target task to be executed. Let's look at the flow of the training. From the datasets, in which the source model is the mobile nets, transfer learning will happen. And then, there will be now the pre-trained model, then the classifier, With this, we can now have the predicted output. After that, we will now link the application to the Raspberry Pi with LCD screen. Since the main goal of this study is for the convenience of the farmers and papaya plant owners, an Android application shall be made with the use of Raspberry Pi mounted with Android OS. The TensorFlow GitHub repository contains an Android project that you can directly load into your Android Studio and compile directly to create an image classifier application. This is for the users, especially papaya farmers, who can use the said system. The phase 4 would now be the system testing. Under system testing, we have step 9, which is testing the device, and step 10 as the accuracy evaluation. For step 9, this is the testing and calibrating step of the research study. The Android application done by the researcher will be used. With the trained model in the computer extracted to the Raspberry Pi, the expected output of this step is a working prototype of the Android application. For step 10, this focuses more on the accuracy of the developed application. The researcher will be testing the captured data from the trained data and see if the prediction is classified into the 4 papaya leaf diseases, healthy, and unknown. Then, it will recommend the treatment or the control of the mentioned papaya leaf disease. Afterwards, the research will gather the data as to how many papaya leaf diseases were detected and identified. The accuracy will be calculated through the use of confusion matrix. Lastly, for phase 5, which is the system deployment. This phase will address the problem of the study. The lack of technology for classifying papaya leaf disease will now be solved. Also, in this phase, it will show if there are problems or recommendations or improvements that are needed for the device. The system will be deployed to a papaya plantation for it to be used in an actual phase. For the block diagram of the system, we have the papaya leaf as the input, and we also have the another three main blocks, which are LCD screen, Raspberry Pi, and the camera module, and they will be powered by a power supply unit. For the setup, let's look at the figure closely. This right here is the Raspberry Pi with LCD screen and camera module, and a little bit of distance to capture the papaya leaf image. For presenting the data, the table shown will be used. For statistical treatment, it must be determined whether the system successfully classifies the papaya leaf disease or not. The principle of confusion matrix will be applied to obtain the accuracy of the algorithm used in this research. The accuracy will be calculated by summing up all the true values and then divided by the total value of both true and false prediction. Shown here is the calculation in the equation, where accuracy is the ratio of the sum of true values and the total number of predictions made by the classifier. BL is the black spot, BR is the brown spot, PM is the powdery mildew, MB is the mealybug infection, and HL is the healthy papaya leaf. That ends my presentation. Thank you so much for listening.